Bismillahirrahmanirrahim. Welcome to supply chain modeling. Today we are going to start module 4, that is production planning and inventory control. This module is further divided into different segments, different subtopics. The first one is sales and operations planning, and that is also called S&OP for short. At the end of this lecture, you should be able to differentiate among 5 levels of a manufacturing planning and control system. You should be able to understand the importance of sales and operation planning as a best practice, avoid imbalance between supply and demand. So we will be discussing different best practices in this course, and one of them is S&OP. You should be able to understand the difference between S&OP for a make-to-stock and a make-to-order production environment. And you should be able to develop the production plan using the two strategies, production leveling strategy and chase strategy. And we will see that this level strategy is used for make-to-stock production environment and chase strategy is used for make-to-order production environment. Whenever we make a plan, we check its feasibility. So in sales and operations planning, when we have made the plan, we check whether it is executable or not using a process that is called resource planning. So we will see how we perform the resource planning and what is its importance. So these are the 4 levels of strategy that we have already seen. So first of all, there is a corporate strategy, especially if the organization has different business units. So it has a one common corporate strategy that is common for all the businesses that it is in. Then for each business, there is a business strategy. And for each function within a business, there is a function area strategy or functional strategy. So for example, production is a function. So organization has a production strategy. The two that we will be discussing are level strategy and chase. So these are 2 examples of production strategy. And there is a hybrid strategy as well that is a combination of these 2. Similarly, sales is a function. So there is a strategy for sales department. There is a strategy for finance department and so on. Finally, there is operating strategy that is used how the function will perform its work in a manner that is consistent with the direction and priorities at the upper levels of strategies. So S&OP is a key manufacturing planning and control process where executive level management meets on a monthly basis and reviews projections for demand and supply and the resulting final impact. So S&OP is a series of structured meetings that are generally performed on a monthly basis. And the future demand and supply are compared and a consolidated plan is made for the next month. So the departments that are directly involved in this process are the production department or operations department that is concerned with the supply, sales and marketing department that is concerned with the demand, and of course the finance department that is concerned with the availability of resources. So S&OP is a decision-making process that makes certain that tactical plans in every area of the business are in alignment with the overall view of the company's business. So there are different conflicts in the organization. And if those are not resolved before making the plan, then the plan cannot be executed. For example, the sales department wants to maximize the level of service. And for that, it requires inventory. But inventory is seen as an investment by the finance department. And in order to provide the inventory, the production department has certain limitations. It has a certain capacity. So at least these three departments are directly involved in deciding the level of inventory that should be produced. So if they are not on one page, then of course, either we will be producing more than required or we will be producing less than required. So that is why this point is very important, that it is a decision-making process that makes certain that tactical plans in every area of the business are in alignment with the overall view of the company's business. So S&OP balances demand and supply. And there are two certain sources, two very obvious sources of demand. One of them is actual orders, actual customer orders or confirmed orders. And the second is demand forecasts. And the sources of supply could be the inventory that is held by the organization. It could be supply orders, something that the organization purchases. And of course, different resources like equipment and machine. So it could be past inventory, it could be something that is purchased, or it could be equipment or plant or machinery. So these are the sources of supply. So both demand and supply should be balanced. Sales and operation planning is based on the interaction of the four fundamental concepts: demand, supply, volume, and mix. Now, one important input to sales and operations planning is strategic planning. Another is marketing planning, and yet another is financial planning. And you could see two direction arrows in these three cases. So they provide input to S&OP, and S&OP also gives input to these planning functions. Now, the focus of S&OP is on the volume. The volume of the product family or a product line that we are planning to produce. And it guides S&OP, as a result, guides the sales plan, that is the output actually of S&OP, and operations plan. And two very important inputs to this S&OP process are resource planning, whether we have sufficient resources to meet this sales and operations plan. And the other is demand management, that actually contains the customer orders, confirmed customer orders, and the forecasted orders. Now, this sales and operation plan further drives master production schedule that focuses on the mix. So what is the quantity of specific products within the product family or product line that was actually discussed in the S&OP. So we here decide the quantities of specific products to be produced and when they will be produced. So the MPS, Master Production Schedule, is more detailed than S&OP, but both must be consistent. So the total quantity planned in MPS should be equal to the quantity in S&OP. So that is very important. So we'll see both in detail, S&OP as well as MPS, as we move on. So we will discuss very briefly these four elements of S&OP: demand, supply, volume, and mix. So when demand exceeds supply, customer service suffers because manufacturing cannot provide the volume of products required by the customer. So that is obvious. When demand is more and supply is less, customer service will affect. Costs increase because of overtime and premium freight rates in order to meet the remaining demand. Quality suffers because of the rush to ship products. And when opposite happens, when supply exceeds demand, we are producing more than what is required, then of course inventories increase because of the imbalance between demand and manufacturing capacity. We may have to go for layoffs, they may result plant inefficiency, they will affect plant efficiency and morale of the employees if we have to go for this option. Profit margins are squeezed because of price cuts and discounting. So you are producing more, so you may have to offer discounts or end of season sales. So as a result, the profit margins will reduce. Therefore, the key to good business performance is to maintain a proper balance between demand and supply. The other two terms were volume and mix. So volume concerns the big picture decisions about how much to make and the production rates for product families. Now, this is also an important topic, how we can actually make the product families. So based on the volume of product family, we decide the mix, and that is basically the concern of MPS. So mix concerns detailed decisions about which individual products to make within that product family, in what sequence and for which customer orders. Smart companies carefully plan their volumes first, then focus on mix decisions. So that is important, that you should plan volumes first and then move to mixed decisions. This is done because volumes are planned effectively, mixed decisions become much easier to cope with. Imbalances in demand and supply occur frequently over the course of a year, and as a result, volume decisions need to be reviewed and adjusted on a monthly basis. So this is something that we will see once we discuss S&OP process, but that is the main idea of S&OP, that on monthly basis, you review the performance of the organization and see to what extent you have executed the plan, what were the anomalies that you want to take care of in future. So as a first step, the data gathering starts at the end of the month, and the formal S&OP process starts at the start of next month. So step number one relates to analysis. That is actually the performance review. So past month's performance is reviewed here, what we had planned to produce, what we actually produced, what were the planned inventory levels, what are the actual inventory levels, what has been the forecast error, and so on. So based on this review, of course, a report is generated, the forecasts are analyzed, and that is an important input to the step number two, that is the demand planning phase. And based on the past month's performance and the forecast for the next month and the inventory levels and customer orders, a demand plan is made by the sales department. And that plan is forwarded to the supply planning phase. That is generally done by the operations department or production department. And you could see here actually that one of the outputs of step number two is management forecast. That's something we discussed in pyramid forecasting topic, that there is a bottom-up forecast, and then there is a business forecast, and then management actually decides the final forecast. And based on that, the forecast for the product families is updated. So that is an important input to supply planning phase. And step number four is where different plans come together, the demand plan, the supply plan, and the financial impacts of the plan. And if there have been some imbalance between these two plans, the demand plan and supply plan, they are resolved. And recommendations are made for the approval in the final meeting, that is executive S&OP meeting. Here, the conflicts, if they were not resolved in step four, are discussed and resolved. Final decisions are made by the top management. Final approval is made about the quantities to be produced. And if financial resources are required, they are also approved. So that is something that everyone agrees upon. And that is actually the action plan for the next month. Now, S&OP details vary from production department, from production environment to other production environments. We discussed 4 in the first lecture. So we are having engineer to order, make to order, assemble to order, and make to stock. These 4 production environments or manufacturing environments. So information needed for S&OP in case of engineer to order, manufacturing environments are product specifications from customer, engineering capacity needed, and project schedule. In make to order, we need demand forecast for product family, design and material specifications from engineering. In assemble to order, demand forecast for product family is also required. And we also require accurate configuration options. And in make to stock, we do need demand forecast for the product family. In this lecture, we will be focusing on actually these 2 production environments, make to order and make to stock. Each manufacturing environment uses different units of measure in its planning process. And this is very important in planning. What are your units of measure? So engineer to order uses generally engineering labor hours, assemble to order environment uses machine and labor hours, make to order uses order backlog, and make to stock uses material supply capacity. So we will see how we actually calculate the backlog in make to order, and there are actually 2 sources of material supply capacity in make to stock. That is production that you are doing every month and finished goods inventory. So we will see how we maintain the levels of the 2 in a make to stock production environment. So there are 4 actually phases in production planning. So first we are having strategic business plan that has a very long planning horizon, but level of detail is less. Then we make production plan that is actually the output of S&OP process that has relatively, this strategic plan generally has a duration of around 2 to 10 years. Then that is converted to annual plan that is also called the production plan that is reviewed actually every month using S&OP process. And this production plan is for product families or product lines that is converted into plans for individual products that is called MPS, master production schedule, smaller planning horizon, but level of detail is greater. And the 4th level is material requirements planning. That is actually the plan for components and raw materials. So planning horizon is even shorter and level of detail is high. So once these plans have been made and the actual final plan is actually the MRP, then that plan is executed and there is a large set of activities in execution, but as a whole, they are called production activity control. So given the objective set by the strategic business plan, this first level, that is a long-term plan. Manufacturing planning is concerned with the quantities of each product group that must be produced in each period, the desired inventory levels, the resources of equipment, labor, and materials needed, and the availability of such resources. These are important decisions that are made while we are making a production plan. So the level of detail is not high. The production plan will show major product groups or families. The planning horizon is usually 6 to 18 months and is reviewed perhaps each month or quarter. So that is the main takeaway, that the original plan that is made at the start of the year is generally for a year or maybe for next 6 months. It rarely actually extends above 1 year. And that plan is reviewed every month using S&OP process. If you have any questions so far, you can ask. As we discussed, that production plan is actually one of the functional plans in any organization. So there is a strategy there should be a strategy to develop this plan. And there are 2 commonly used strategies to develop a production plan: the production leveling strategy and chase strategy. And we can use a combination of these, and that is actually also very common. We use the combination of these two strategies, and that is generally called hybrid strategy. So first we will discuss production leveling strategy. Continually producing an amount equal to the average demand. So we decide a quantity based on generally the annual plan, and we produce that quantity on average. Now this average could be on a monthly basis or on a daily basis, but we are producing roughly the same quantity every day. Sometimes demand will be less than the amount produced and inventory will build up. And at other times, demand will be greater and inventory will be used up. Now, the advantages of this strategy are that it results in a smooth level of production that avoid the cost of changing production levels. There is no need to have excess capacity to meet peak demand, but keep in mind that demand can be greater than capacity, but we can make some short-term arrangements for that. But in general, we do not need to have excess capacity. No need to hire and train workers and lay them off in slack periods. So the level of workforce is stable because the level of production is quite stable. The main disadvantage of this strategy are actually two. One is written here. The first one is inventory will build up in low demand periods that will cost money to carry. And the second disadvantage is opposite to this, that when demand is greater than what we are producing, then back order can occur. So that is also a big disadvantage of this approach. Of course, there are different approaches to address this problem, but we are either building the inventory when demand is less than what we are producing, but if other way around happens, then there is a risk of back orders. That is, we cannot actually satisfy the customer demand. So this is the basic idea that demand varies from time to time. Of course, this is just an illustration. We will see that basically leveling strategy is used where there is not big variation in the demand. But for example, in this case, for the first half of the year, demand is less than what we are producing. So this line is showing the average quantity that we will be producing. So for the first 6 months, what we are producing is greater than the demand. The solid line is the demand curve. So here inventory will build up. And here for the rest of the year, we are producing less and demand is greater. So here that inventory will be used up. But of course, it could be other way around as well. So in that case, we can face back orders and we have to plan how we can actually avoid the back orders using certain short-term arrangements. And of course, practically, this level of production can slightly vary because of certain reasons. But this figure is giving the basic idea. Now, how we can decide this average quantity? How much should it be? So that is equal to total forecast for the planning horizon. So planning horizon is very important term. So generally it is from 6 months to 1 year. So what is the total forecast for the planning horizon minus opening inventory plus planned ending inventory at the end of planning horizon? So that is the net demand actually that you are having divided by number of periods. So if you are making the plan for next 1 year, then number of periods will be 12. The total forecast minus opening inventory at the start of planning horizon plus planned ending inventory at the end of planning horizon divided by number of periods. So that will give us average amount that we should be producing every month. But I repeat that you could convert that average amount into daily average amount as well. by dividing this quantity by the number of days, number of working days in a month. Here we are talking in terms of number of months. So production plan for each period, in this case, a month will be total forecast for next 6 months or 1 year minus opening inventory plus planned ending inventory divided by number of periods, for example, months. Actual inventory in a period or in a month T will be equal to actual inventory in the previous period, period T minus 1, plus actual production in this period T minus actual sales in this period. So these two quantities are actually showing what is the amount of inventory that you are having. This is something that you are having, minus this is something that you have delivered. So the net is the actual inventory at the end of period T. So previous period's inventory plus this period's production minus this period's sales. Now, this inventory can be converted into inventory in terms of number of days. And that is equal to this inventory that we calculated at the end of certain month divided by daily planned production for next month. So the basic idea is that whatever inventory we are left with at the end of the month, how much that inventory is worth in terms of number of days for the next month. So that is the basic idea. For example, if we are talking about June, so we have come up with a certain inventory at the end of June. Now, what is this inventory worth? The planned production for July. So this inventory divided by daily planned production for the next month will give us this inventory in terms of number of days. So actual inventory in period T divided by daily planned production in period T plus 1. So we can convert this monthly production plan into daily by simply dividing by number of days. So whatever quantity we came up here, so for a period T plus 1, that will be the same because that is the average quantity we are planning to produce every month. So that quantity divided by number of days in that month. So that will give us this denominator, this thing using this formula. So planned production for next month divided by number of working days in that month will simply convert the inventory that we have in terms of number of days. So I hope you have got the idea. So this is the basic formula. And in order to find the denominator, we have to use this formula. So daily planned production is monthly planned production divided by number of days. So we are talking about this, everything is for July, for example. So planned production for July divided by number of working days in July. And this is the ending inventory for June. Next important formula is number of workers or machines required, because we have to perform resource planning as well. So we will see resource planning toward the end of this lecture. But one of the important parts is to find the number of critical machines and workers that are required. So that is equal to daily demand over daily capacity, or daily workload divided by daily available time. Of course, the units could be different than above, but they should be consistent. For example, we could use monthly demand divided by monthly capacity, or monthly workload divided by monthly available time. So we'll use these formulas, but again, I would reiterate that the production leveling strategy is more appropriate for make to stock products, or we can say that it is more appropriate for functional products. The products that have a stable demand, the products that do not have trend or they do not have seasonality in the demand pattern. So this is an example of the grid that we will be using. So this grid has three parts. So we are having sales, we are having production, and we are having finished goods inventory. So these are three sections in this grid. And the most important input is the forecast. And here our planning horizon is a year from January to December. And time bucket is a month. So we are talking in terms of months. So planning horizon is a year and planning period or the time bucket is a month. So we are given the forecast for the next year. We can add these forecasts to get the total forecast, and then this total forecast minus starting inventory plus ending inventory divided by the number of months, that is 12, will give us the average quantity that we should be producing every month. And again, we can convert this quantity into average quantity that we will be producing every day if required. Then we will have actual sales, actual production, and actual inventory. So in each part of this grid, we will see the difference of actual and forecast to see the overall difference. So what is the difference of actual sales and forecast in January and February, March, and so on? And what is the difference? And we can actually apply some formulas to see whether that difference is within acceptable range or not. Similarly, what was the planned production, what has been the actual production, and what has been the difference of the two, and what has been the planned level of inventory, and what has been the actual inventory, and what has been the difference of the two. And in this case, just as an illustrative example, the organization has a policy to keep an inventory of 1,000 units every month, but of course, it can be different amount in different periods. Then depending upon the demand every day and the capacity of the critical departments every day, we can calculate the resources required in that department. Now we will solve this S&OP grid using Excel. So here we are having a planning horizon of 1 year and our planning period is a month. So we are given the forecast for the next 12 months. So that forecast equals, by adding these amounts, it equals to 24,750. So the average quantity that we should produce every month will be equal to this total forecast minus inventory that we are having at the start of the planning horizon, plus the inventory that we plan to have at the end of the planning horizon. So just remember that in the production planning logic, whenever we are talking about the ending inventory, that is, of course, the inventory at the end of that month. So here 1,000 means that is 1,000 that we should have at the end of December. So total forecast minus opening inventory plus planned ending inventory divided by number of periods is 12. So that is equal to 2,050. So we are planning to produce 2,050 every month. Now, current period is the month of May. So of course, we did have certain actual sales for the first 4 months, and we did have some actual production for the first 4 months. And of course, there would be actual inventory, but we have to calculate that. And once we apply the formula to calculate actual inventory, we can actually cross-check physically whether that inventory is in the stock or not. So that is something we will discuss in detail in our topic of inventory management. So there is a certain tolerance that is allowed, some difference that is acceptable between actual inventory and the inventory that the record is showing. For some critical component, it is 0%, there is no tolerance, but for some components, we do have some tolerance. So we will discuss that in different approaches to inventory counting. in our discussion on inventory management. So these are two things: what you actually have that we are calculating here, the actual inventory, and what the records, what is in record, and what is the actual inventory that is physically present. So we can calculate the difference of actual sales and forecast. So actual minus forecast. I hope you remember that this is called forecast error. So we have calculated the forecast error for the first 4 months. Now, the cumulative difference of this forecast error needs to be calculated as well. So the cell D9 up to D9 will give us the total forecast error for January. We can fix the first D9 cell and then simply drag to calculate the cumulative difference. So you could see that for the first 4 months, the total difference is 400. So A minus F, sum of A minus F is 400. So that simply means that what we have produced, actually what we have sold, actual sales. So what we have sold is greater than what we forecasted to sell. So actual sales are greater as a whole for the first 4 months than the forecast sales. Of course, that is in general something good. This difference as a percentage, so A minus F over A. So this difference as a percentage of actual demand will be equal to this difference divided by sum of actual sales. So for January, that is equal to 2,150. So we can use the column and fix the first D8 cell. So that will give us a percentage of plus 6.98%. So cumulative difference of actual sales and planned sale for January is 6.98%. And it is 4.73%. So this is equal to cumulative difference divided by sum of the actual sales. Similarly, we had a certain plan to produce a certain quantity, and then we had actual production, and you could see just like actual sales, they were somewhat different than the forecast. So actual production is also somewhat different than the planned production. And that could be for different reasons. It could be because of the downtime of the machines or unavailability of the material. So there could be different reasons. You could calculate the difference of actual production and planned production for the first 4 months, and then have a cumulative value of the difference. You can fix the first D16 cell in this case. So you could see that the cumulative difference has been minus 100 till the month of April. So we have produced slightly less than what we plan to produce. 100 units produced are less than what we plan to produce. And then this difference has a percentage. So this cumulative difference divided by sum of actual production. So again, we can fix the first cell. So the cumulative difference of January divided by the actual production of January, minus 5.13%. And we can drag. So for example, this one is equal to cumulative difference till April divided by the sum of actual production till April. Finally, we have to make calculations for finished goods inventory. So we are having a planned finished good inventory of 1,000 at the end of each month. So actual inventory, you could see the formulas they are written here on the right side as well. So actual inventory in January will be equal to actual inventory at the end of previous planning horizon, plus we are having actual production. So actual inventory from previous period plus actual production in this period minus actual sales. So this is the actual inventory that we are having. Similarly, for February, it will be equal to actual inventory from previous period plus actual production in February minus actual sales in February. So in this way, we can calculate the actual inventory. Similarly, we can calculate the difference of actual and planned for the first 4 months in this case. We can have the cumulative difference. Fix the first D23 cell in this case so that we can drag the formula. So you could see that the cumulative difference has been minus 450. So actual inventory that we are carrying is smaller than what we plan to carry. And we can calculate the difference as a percentage. So this cumulative difference divided by the sum of actual inventory till that period. Fix the first cell. So cumulative difference as a whole has been minus 12.68%. So as a whole, we are having actual inventory that is less, that is 12.68% less than what we plan to have. Now this inventory in each period can be converted in terms of inventory in terms of number of days. For example, this actual inventory of 950 at the end of January is worth how many days of planned production for February. So this will be equal to this inventory, actual inventory in that period divided by daily planned production for February. Monthly planned production for February is 2050 and we are having 20 working days. So that is a daily planned production. So monthly planned production divided by number of days. So this inventory of 950 at the end of January is worth 9.27 days of planned production for February. So that is important. Similarly, this inventory 1000 in February, this 1000 divided by planned production, planned monthly production for March divided by the number of days, number of working days in March will give us inventory in terms of number of days. So that is equal to 9.76 days for the month of March. So this inventory 1000 is worth the 9.76 days of planned production for the month of March. Similarly, you can make calculations for March and April. So as we don't have the actual inventory for, so as we are not having the actual inventory for May, so the inventory on hand for May is 0. But once we get some amount here, we can have actually that inventory in terms of number of days for June. Now in S&OP and master production schedule, we match the plan against the available resources. That is something that we will do toward the end of this lecture, but we do need to have an idea how many resources will be required. But remember that resources could be number of machines, number of workers, it could be space required as well, or it could be some other resource as well. So here the monthly planned production is 2050. So this 2050 divided by number of days gives us the daily demand. Now the number of resources equal to daily demand divided by daily capacity. So this daily demand divided by the daily capacity in department 1 or daily capacity for machine number 1 gives us number of machines equal to 10.3, or we require 11 machines. Similarly, if for department 2 or work center 2, we do the same. Daily demand divided by daily capacity. So we require 5 machines, and same is true for work center 3. Daily demand divided by daily capacity. So we require 21 machines. So this is how we can have an idea of what actually we plan to sell, what we actually sold, what we plan to produce, what we actually produced, and how much inventory we plan to have and how much inventory we actually had. So you could notice that this is actually the sales plan, or this is actually the demand plan that is helping us to decide the production plan. So this 2050 actually came from this forecast. That was the main input, plus of course, the starting inventory and ending inventory. So the main input to this whole process is demand planning, that is sales planning. And based on that demand plan, we made the production plan, and that actually helped us to maintain a certain level of inventory. And this is a make to stock environment, so the demand is generally met through the finished goods inventory that we are carrying. So these are actually the basic steps in S&OP as well. So first there is demand planning. Then there is, first there is demand planning or sales planning. Then there is supply planning or production planning. And of course, we have to match these plans with financial resources as well. And we could actually apply certain formulas, logics to see whether this difference is within certain acceptable limits or not. But whatever we are having, the difference that we are having at the end of each month, whether this is a difference for sales or production or finished goods inventory, becomes an important input for the next month's S&OP meeting. So here is a summary of benefits and risks of using production leveling strategy. Benefits include stable labor costs because we are having a stable production rate, improved quality control because of consistent production quantity. We can devise a solid quality control system, better cash flow, minimum smoothing costs. We do not need to adjust the production levels. So that cost is minimized. So is the cost of hiring. And actually first and the last point are related. So we are having stable workforce. So the labor costs are also stable. The risks include cost of carrying excess inventory. Inventory is an asset. So the more inventory you have to carry and the longer you have to carry it, actually, the longer you are actually having your cash tied up in the inventory. Subcontracting or overtime costs when the demand is greater than your capacity or the sum of the capacity and inventory, then you have to go for the subcontracting or overtime. And if you cannot meet the demand in a certain period, there is a back order cost, that is unfulfilled customer order. That is also called lost sales, cost of lost sales. Cost of expedited shipping in some cases. You have to ship the product quickly to the customer, so that costs you more. Loss of customer goodwill, especially once you cannot meet the demand. And as the plan is based on forecast, and forecasts are generally wrong, so that sometimes results in either producing too much or producing less if our forecast has big forecast error. The second type of production strategy is chase strategy. So in this strategy, the organization produces the amounts demanded at any given time. So just opposite to level strategy here, inventory levels remain stable while production varies to meet demand. In leveling strategy, we had stable production, but we had variable inventory levels. Here it is opposite. Company must have enough capacity to be able to meet the peak demand. Now, the capacity strategy is also very important topic. There are different strategies to maintain certain capacity, but in such scenarios, apart from a certain amount of capacity, the organization also needs to have some safety capacity. Safety capacity. So safety capacity is a risk management approach in such scenarios where the demand varies a lot. So above a certain amount of capacity, the organization needs to have excess capacity in order to meet a sudden increase in demand. So that is called safety capacity. So this chase strategy may involve hiring and training as well as laying off employees. So that is a big challenge as well. Sometimes they have to put on extra shifts or overtime as well. So safety capacity can take different forms. So it could be in terms of some idle machines that are used in certain situations, or it could be extra shifts or overtime. The advantage of this strategy is to keep the inventory to a minimum. And it is used when inventory holding costs are high and cost of changing capacity are low. Specifically speaking, this approach is common with make to order and engineer to order production environments where we do not produce the final product unless we receive the customer order. But we will see later that level strategy and chase strategy can be combined in certain situations. So they can be combined for certain make to stock products as well. So whatever is the demand, this is the demand curve, we produce according to that demand. So that is the basic idea, that we produce as per demand. So that is the basic idea of chase strategy. As I mentioned, that it is more common for make to order and engineer to order production environments. So here basically we require formula to calculate the backlog. So we are having a planned backlog and we are having actual backlog. So backlog is actually the order that you have received from customer, but you have not yet delivered it. So that is the backlog. So just keep in mind that backlog is different than back order. Back order is the lost sale. You couldn't meet the demand of the customer. And backlog also does not mean the late order. So you received a certain order and you have committed to deliver it after a month. So that is the backlog, the order that has to be shipped. But of course, if you cannot deliver it as per a promised date, then it becomes a late order. So we are having a planned backlog. Every make to order organization is actually having some backlog. So it sets the limits of the maximum backlog that it will carry. So we call that planned backlog. So that is equal to planned backlog from the previous period. So planned backlog in period T is equal to planned backlog in period T minus 1 plus forecasted orders in this period T minus planned production in period T. So these two quantities are actually what you have to deliver. And this is what you plan to have. Similarly, actual backlog will be equal to actual log from previous period plus actual orders in this period minus actual production in this period. So again, this is something that you have actually delivered. Sorry, this is something that you have to deliver previous quantity plus this period's order. So this is something that you have to deliver. And this is something that you have delivered. That you have delivered. So what you had to deliver from previous period plus in this period minus what you have actually delivered in this period is the actual backlog. So this is just the opposite to the formula that we used to calculate finished goods inventory. So I hope you can link this to that formula. So these are the two formulas that we will require, one for planned backlog and the other for actual backlog. And of course, we can see the difference of the two to see whether the backlog is within acceptable limits or not. Now we will solve S&OP grid for a make-to-order production environment using chase strategy. So this is an S&OP grid for a make-to-order production environment using chase strategy. So we are having bookings in the first section. Then we are having production or shipment, and then we are having order backlog. So this booking is very similar to the sales portion of the make to stock grid. This production part is very similar to the production part of the make to stock grid, but this last part is slightly different. So here we have to make the forecast as well of what we are expecting, and then there will be actual orders, and similarly, we will plan some production according to this forecast, and then there will be actual production. So we can actually calculate the difference in order to see whether we are having more than we planned or we are having less. So the difference of actual orders and the forecast is the forecast error. So let me see. Actual orders minus forecast is the forecast error. Then we can have the cumulative error. So we can sum these errors together to calculate the total errors. So we can fix the first cell to drag the formula. And then of course we can have this difference as a percent. So this cumulative difference divided by sum of the actual orders. We can fix the first cell, so that will be equal to difference as a percentage. As a whole, for the first 4 months, we are having actual orders less than the forecast. That is something that the negative difference is showing. Similarly, according to this forecast, we had planned production, and you could see here that as a whole, the planned production is less than the forecast. And similarly, as a whole, the actual production is less than the orders that we received. And that could be practically because of the limitations on the capacity that the organization has. And this is an illustrative example. Practically, this difference could be even greater. So actual production minus planned production is the difference of the two. Then we can have the cumulative difference. Similarly, we can see the difference as a percentage. So that will be equal to this cumulative difference divided by sum of the actual production. Now here you could see that for the first as a whole, there is little difference of actual production and planned production. So as a whole, we have produced and to produce. So that is something good. Now, important part of this grid is the backlog. So we need to have a planned backlog and we need to have actual backlog. Now you could have a planned backlog as a policy, just like we saw the finished good inventory in make to stock grids, that as a policy organization plan to have a finished good inventory of 1000, or you can calculate it using formula. So as we discussed, that planned backlog in a certain period is equal to backlog from previous period plus forecast orders in this period minus planned production in this period. So that is the planned backlog. For January, similarly, you can calculate for the rest of the months as well. Similarly, actual backlog will be equal to actual backlog of January will be equal to actual backlog from previous period plus actual orders in January minus actual production in January. Similarly, actual backlog in February will be equal to actual backlog in January plus actual orders in February minus actual production in February. Right? So actual backlog plus actual orders. That is something that you actually are owing, something that you have to give to the customer. And actual production is something that you have provided the customer with. So 27 plus 49 minus 42. 34 is the actual backlog, something that you still have to deliver. So this is how you can calculate the actual backlog. And similarly, you can calculate the difference of the actual and plan, just like we did for bookings and production. And you can have the cumulative difference. So that is the cumulative difference, and you can calculate the difference as a percentage. So cumulative difference divided by sum of the actual backlogs till that period. So that will give you the difference as a percentage. So you could see that as a whole, the actual backlog has been less than the planned backlog. So that is something good. You are producing faster, you are meeting the orders faster than you plan to meet. Now this backlog can be converted into backlog in number of days or number of weeks. Here we will be making calculation for number of weeks, but you could do the same for a number of days as well. So the basic idea is that this backlog of 27 at the end of January is how much backlog for the next month, that is the February. So you can convert it into backlogs in terms of number of days or number of weeks, just like we did for the finished goods inventory. We converted finished goods inventory into number of days. So I hope you have got the idea. Now, for example, this actual backlog of 27 can be converted into backlog in terms of number of weeks. So that will be equal to this 27 divided by planned production for February. That is 45 divided by 4 if you are going to convert this backlog in terms of number of weeks, or you will divide by the number of days in the month if you want to have this backlog in terms of number of days. So in terms of number of weeks, it is equal to 2.4 weeks. So this backlog of 27 is worth the planned production of 2.4 weeks for February. So you have to work 2.4 weeks extra apart from this planned production of 45 in order to meet this backlog. So that is the basic idea. Similarly, this backlog of 30 divided by the planned production for March, that is 50, divided by 4 if you want to have backlog in terms of weeks, or of course, divided by number of days if you want to have backlog in terms of number of days. But here we are calculating for number of weeks, so divided by 4 will give us a backlog of 2.72. So this backlog at the end of February, this backlog of 34 is equal to a backlog of 2.72 weeks for March. And similarly, you can make calculations for April, May, and so on. So this backlog of 35 at the end of April is worth a backlog of 2.80 weeks for April, for May. So this 35, backlog of 35 is equivalent to a backlog of 2.8 weeks for the month of May. In other words, you have to work 2.80 weeks extra in May to meet this backlog. So that is the basic idea. So you can set the limits of maximum backlog that you want to carry in order to have a check whether you're moving as per plan or not. But as a whole, you can see that it is around 2.4, 2.7, 2.8, around 3 weeks. So the basic takeaway here is that, again, you are forecasting certain orders and you are having actual orders and you are making plan according to the forecast. According to the forecast, and you are doing actual production according to the orders, and there is a difference. Again, you can set the limits, but the most important part is this backlog. The lesser the backlog that you are carrying, the better it is. So this is a summary of benefits and risks of chase strategy. The benefits include that you can change output capacity to meet demand, but in order to make sure that you can do that, you need to have flexible workforce, flexible equipment, and you do need to have safety capacity as well. And of course, the inventory carrying costs are low as compared to a production leveling strategy, but you do need to have some inventory, especially the inventory of raw material. The risks of this strategy are high smoothing costs. So you have to vary production from low to high and high to low. So you have what are called capacity related cost. Availability of an appropriately skilled workforce can be a challenge. Erratic utilization of plant and equipment. So sometimes you are producing more, sometimes you're producing less. So underutilization of resources and non-stable utilization of resources is also quite tricky to manage. And finally, you have insecure and unhappy employees. So especially you are hiring seasonal workforce. So you hire that workforce during peak season and lay them off during non-peak season. So that is, of course, not good for the organization in the long run. So that poses challenges to maintain highly skilled or appropriately skilled workforce. Organizations can use the level strategy and chase strategy in combination, and that is called hybrid strategy. It combines the elements of level and chase production. So organization keeps the plant running near full capacity for part of the cycle, allowing inventory to build up. So that is basically level strategy. And the organization slows or shut down to allow the inventory to shrink as customers buy the product. So that is basically chase strategy. For example, Lego manufactures the toy building blocks using one shift for the first half of the year. So that is basically a level strategy, and adds another shift in the second half of the year for holiday season to meet the increasing demand. So that is basically the chase strategy. So this strategy is very common for the products that are seasonal in nature. So they are having high demand in part of the year, and they are having low demand in the rest of the year. So generally, during the off-peak season, the organizations go for the level strategy. Just we saw in the case of Lego manufacturers. And during peak season, the organization goes for chase strategy. And this is a very common approach for seasonal products, like, for example, air conditioners or some clothing for the winter. So this approach is generally used. So benefits of hybrid strategy include it balances large fluctuations in demand. So that was sort of risk in the chase strategy. So that is catered for here. It takes into consideration volatile demand and smooths out seasonal demand. So all these are actually very much related, that this strategy helps us to cope up with the random changes in demand. Risks include availability of an appropriate skilled workforce, the same challenge we had in the chase strategy. And here a high level of coordination. A high level of coordination is required between different departments because of the varying nature of the demand. So you could have a stable and a systematic approach in level production, but here that will not work, and you should be ready to cope up with the unexpected changes in demand. Whenever we make any plan, we check whether it is feasible or not. So same is true of S&OP. So the production plan that we have made as a result of S&OP process, we have to validate it against the available resources. So the process is called resource planning or resource requirements planning. So resource planning serves as a capacity check on the production plan. So it determines bill of key resources or the list of resources for each product family in the production plan. There are two primary objectives when it comes to resource planning. First is to evaluate the feasibility of the production plan generated during S&OP. And the second is to address the adequacy of the resources that have a long acquisition or installation lead time to make sure they are available when needed. So if the resources are sufficient, well and good, but if you need extra resources, then sufficient arrangement should be made before time. So these resources could be made machines, equipment, or the labor or outsourcing that is required. One very important aspect of resource planning is unit of measure of each resource. So for labor and machines, it could be number of hours, labor hours or machine hours. It could be head counts, especially if the resource required is providing some service. So you might be more interested in the number of people that are required, or it could be tons of output or volume of output. And in the case of storage, it could be the area that is required, or it could be some other unit of measure, but you should be very clear about the unit of measure. So these are the steps in resource planning. So first you have to determine the bill of key resources or the list of resources for each product family in the production plan. You have to determine the unit of measure for each key resource. Then you have to determine the capacity availability for each resource by period. So for example, if you are making the plan for next month, so you should have the capacity availability data for each day of the month. Then you have to calculate the load on each key resource by time period. So load means demand. So that is important. And in step number 5, you have to compare the load to available capacity in each time period for each resource. So if in each period load is less than the available capacity, well and good. If not, then you have to either look up for new resources if they can be made available, or you may have to revise the production plan, or you may have to adjust the capacity. So this decision is to be made. So first you need the bill of resources. The resources that are required during that planning period. So that is called bill of resources. And generally bill of resource is the capacity required for a unit product or a batch of products. So for example, in this case, this bill of resources is for 1,000 units, but it could be for 1 unit or say other batch size as well. So for example, in the planning horizon that we are talking about, we have to produce 4 product families, and we need machining time, we need some space for packaged product, we need 2 types of labor, non-clean and clean room labor, and we need some oven curing space. So these 5 resources are required. And you could see that for labor and machine, the unit of measure are hours, and for space, it is cubic feet. And for other resource, it could be a different unit of measure. So to produce 1,000 A products, we need 5 hours of machining. To produce 1,000 B products, we also need 5 hours of machining. For C, 10 hours, and for D, 1 hour. Now to store the packaged product space, we need 10 cubic feet for 1,000 A products, 10 cubic feet for 1,000 B, and same for C, and 20 cubic feet for 1,000 D products. You could see that for product family A, to produce 1,000 units, we require 75 labor hours. For product family B, we require 15 labor hours, and so on. And you could see for the second type of labor as well, and you could see the space requirement for oven curing space as well. So these all requirements are for a batch of 1,000 units. Now this is the bill of resources. Now based on the load in certain periods, say next month, we can calculate whether we have sufficient resources available or not. So for example, this is the data that we have come up with from S&OP process. So we have to produce 100,000, everything is in thousand. So we have to produce 100,000 A products, 80,000 B, 40,000 C, and 60,000 D. Now we can simply multiply the factors from this table. So produce 1,000 A, we needed 5. So for 100,000, we will need 500 hours. Similarly, you could see that we need 10 cubic feet space for 1,000. So for 100,000, we will need 1,000. So this 10 multiplied by this 100. So that will be 1,000. So you could see the other values as well. So just for example, for product D, we require 1 labor hour for 1,000 units. So for 60,000, we will require 60 labor hours. So you could simply multiply the quantities from the previous table with these quantities to come up with these figures. So we can add these values together to calculate the total load. So total load on the machining is the sum of these 4. So that is 1,360. Total requirement for the packaged product space is the sum of these 4. So that is 3,400. And similarly, you could see the other values. And of course, we have certain capacity of these resources as well. So we can divide the total load by capacity available to calculate load as a percent. So if the load is below 100%, then that resource is sufficient to meet the demand. And if it is greater than 100%, then that resource is overloaded. So again, we could go for either of the options here in last step, either to acquire new resources or to revise the production plan or to adjust the capacity if possible. So this is how the resource planning is conducted. And here is another example that we have a bill of resources for certain product families, how much machining time is required, how much welding time is required, how much assembly time, how much space is required. So again, these values could be for a unit, for one product, or for a certain batch of products. And again, we have the capacity for each of these resources as well. Now, depending upon the load in a certain period, we can calculate the load percent for each of these 5 resources and see whether that resource is underloaded or overloaded, and then make the adjustments if required. So this is the summary of resource planning process. The inputs to this process are product family groupings. Just in the previous examples, we had 4 product families, the production plan. So these quantities are the production plan quantities from S&OP, bill of resources, including units of measure, and estimates of capacity. So you saw all these elements in the previous examples. So we have to calculate load on each resource and then compare the load to available capacity. And if there are imbalances between supply and demand, we have to adjust the load or capacity or acquire new resources if possible. So this is very important that whenever we make a plan, we check it against available resources before execution and make adjustments if necessary. So this was overall S&OP process. We saw how it is, what is the basic of S&OP process, what are the steps. It is a structured approach, and what is actually discussed and decided in each step. And one important part of S&OP process is the supply planning. So we saw 2 approaches to supply planning, or the production planning, the level strategy and chase strategy. And then we saw how we can perform resource planning in order to check the feasibility of that production plan. So if you have any questions, you can ask.